All right, for this question, Richard has saved 83% of the money that he needs to buy a skateboard that costs $150. How much more does he need to save to buy the skateboard? Okay, so the big idea is percent of a number. The strategy we're going to use is process of elimination and also drawing a picture to kind of understand what the problem is talking about. Okay, so far he saved 83% of the money that he needs to buy the skateboard. The skateboard costs $150. And to use process of elimination, we have to have multiple choice. So here's the multiple choice answers. We're going to eliminate the ones that don't make any sense, and you'll see that there's probably just one that does make sense. And there are two that definitely don't make sense, one that's not too good, and it only leaves one left. We could probably pick out the right answer. Okay, so to help us understand which ones to eliminate, the picture that I'm going to draw is a circle, kind of like making a pie chart. Okay, so in the circle, this represents the skateboard cost, the full price of the skateboard. So this circle represents $150. All right, we're going to then cut this into two parts. The two parts are going to be how much has he already saved, how much does he still need to save. For example, if he had saved 50% of the money, that means half, and we would cut it right in half, and we would say he's already saved half, he needs to get the other half. But he's actually saved 83% of the money. So think about how we would draw that. Like if it was 25%, that would go like this. 50% would be half. If it was 75%, it might go like this, where this is 75%. But he saved even more than 75%. He saved 83%. So that's going to be a pretty big pie piece to represent 83%. It's way more than half, right? In fact, it means he saved almost the whole thing. The whole thing is 100%. He saved almost all of what he needs. It might look something like this. So this part represents what he's already saved. And this part over here represents what he still needs to save. So we're looking for this part right here. Okay, so if the whole thing is $150, that's the total price, and he saved almost all of what he needs, then the amount left needs to be just a little bit. It's well less than half of 150. So let's eliminate the ones that don't make any sense. We know that what he needs to save is way less than half of 150. All right, you see any numbers that we could eliminate that don't really fit the bill? This one is way too big because this says he needs to save almost all of the money. He's already saved almost all of it. By the way, that brings me to distractors. We talked about distractors before. If you figured out 83% of 150, that's what that number is. That's 83% of 150. He doesn't need to still save 83% of 150. He's already saved 83% of 150. But that number is the distractor. Okay, 83 is also a distractor. 83, just because it's 83%, doesn't mean it's $83. And again, we know that he needs to save less than half of 150. That's not less than half of 150, so that's not right either. So by using this process of elimination, and by drawing the picture so we kind of visualize what we're talking about, we now only have two answers left. So think about which one makes sense. Again, it's less than half of 150. Is it close to one half of 150? Or is it not even close to half of 150 that he still needs to save? Based on that, you could probably guess which one is the right answer. And if you had guessed $25.50, then you used process of elimination, and you've used this picture to kind of estimate how much he's already saved, how much he still needs to save to figure it out. Okay, let's talk about how we could get it with a more mathematical solution. So again, I think we could guess the right answer without really using any actual numbers with math, more like the ideas of what's math sense in this problem. But let's actually use some numbers. We'll do some calculation to get this as well. All right, so when you're finding percent of a number, the of tells you to multiply. Let's say we wanted to find 83% of 150. Here's how you would do that. You take your 150, of means multiply, so it's 83% of 150, 83% times 150. But remember, 83% is not actually 83. You need to move that decimal twice, so it's actually 0.83. 83 hundredths. So that's back to converting fractions and decimals and percents. So if I multiply 0.83 times 150, let's see what happens. The decimal has 2 decimal places, it goes right there. And there's that answer of 124.50. Like I said, that was going to be the distractor. So for somebody that knows how to find percent of a number, they might just go, I'm going to find 83% of 150. And then they would choose the wrong answer. But that's why kind of process of elimination and drawing that picture to really understand what this problem is asking, it actually makes no sense that it's 124.50. But that's because 83% is how much he's already saved. We're not supposed to find out how much he's already saved. We're supposed to find out how much he still needs to save. So if we know how much he saved, which is this much, and if we know how much the skateboard costs, which is this much, what can we do now to figure out how much he still needs to save? And if you thought we should subtract those numbers, you're right. So we can take $150, which is the total amount for the skateboard, take away the money he's already saved, which is $124.50, and whatever is left is how much he still needs to save. Do some borrowing there. Looks like he still needs to save $25.50, which is the answer that we got by using process of elimination. So again, sometimes there are problems where you could use process of elimination, and if it's multiple choice out of 4 answers, you could pretty much eliminate 3 of the 4, and then there's only 1 left. Sometimes you could eliminate 2 of the 4, and then at least you have a better chance of guessing it than you did to begin with. And sometimes it's a great strategy. Sometimes actually doing the math like this is a great strategy, and you've got to know when should we actually do the math, when should we use process of elimination. But one thing is, if you get stuck on a problem that you just absolutely don't know how to solve mathematically, still don't give up on the problem and take a wild guess. So wild guessing is not a good strategy, but maybe draw a picture to think about what the problem means. Maybe you could eliminate 1 or 2 of the answers, and then instead of a wild guess, you've got an educated guess, which is probably going to be right. So I hope you learned something from this strategy.